So in the last class, we have discussed directory structure, how we are implementing our directory structure in two level, as well as in the tree structure directory levels. Now today, we are going to discuss file sharing. What are the access rights that we can give to a particular file? If you are sharing a file with different types of users, then what are the permissions you can directly set on your files? What are the issues? There are two issues arise when allowing sharing, file sharing to be shared among a number of users, that is access rights and the management of simultaneous access. What are the access rights you are providing to the end users and management of simultaneous access? How multiple users can directly access the same. Now, how many types of access rights you can provide to the user? These access rights you can provide in any of the particular file. First one is none. That means the user would not be allowed to read the user directory that include the file. That means you have given exactly no rights. User cannot touch your data. Okay. Then the knowledge. The user can determine that the file exists and who its owner is, and can then petition the owner for additional access rights. User can see what is the information regarding that file, but user will not be able to read or modify the contents of that file. Suppose you want to download some paper from some research agencies like IEEE or Springer. So there you are able to see the author details, references and all, but the full text you are not associated with. You cannot access the full content without the permission of that publisher. The execution. The user can load and execute a program but cannot copy it. It is clearly mentioned that you can use that file, you can open that file, but you cannot copy it for your own purposes. Then the reading. The user can read the file or any purpose, including copying and execution. User can copy, user can execute, user can read the data, but user is not allowed to update the same record. Appending. The user can add data to the file, but cannot modify or delete any of the file contents. Suppose I am giving you a PDF or a doc file consisting of 5 pages. You can add 2 more pages in that file, but you cannot delete any single content from that file. You can add, you can include some more content, but you cannot delete the existing ones. Then the updating. The user can modify, delete, and add to the files data. Now you can be able to change the contents. You can be able to delete the file contents. Then the changing protection means the user can change the access rights granted to other users. Now changing protection means I want to change the access rights for the particular file. Now you will be able to change that. And then the deletion, the user can delete the file from the file systems. Now here user access rights are mentioned. Owner, what owner can do? Usually the initial creator of the file, it has full rights. Many grant rights, may grant right to others. This is the owner of a particular file. If you are the owner or the creator of a particular file, then you can have full rights on that particular file, may grant other rights to the other users. Specific users, which I am selecting that some person is allowed to change or modify the contents, that is specific users. individual users who are designated by the user ID. I'm giving you some user ID and password for the same, and then you are allowed to change the contents of that particular file. Then user groups, a set of users who are not individually defined. Like I am giving my file in your project group. Your project group is consisting of 4 different members, and all 4 may change a certain data. But I am giving you a unique ID for your project name, not for the individual ones. That is the user group. I am giving some permission to your group, not the individual members of the group. That means I cannot identify that out of 4 members who is going to change the data, but I will blame only the complete group. Then the all means all users who have access to the system. These are public files. I'm giving some rights to all the users that anyone can come and change the data itself. So it will be coming in all user rights. Now the file allocation part. That is another topic in the file system. On secondary storage, a file consists of collection of blocks. The operating system or file management system is responsible for allocating blocks to files. The approach taken for file allocation may influence the approach taken from free space management. Space is allocated to a file as one or more portions contiguous set of allocated blocks. Now, what is file allocation table? That is FAT. Data structures used to keep track of the portions assigned to a file. Now, what is the basic behind the file allocation? Actually, we are going to discuss different types of file allocation methods. Why this is required? If you want to store a large file in your secondary storage, I am talking about this secondary storage. So your file must be uh, broken in some smaller parts so that these parts may be allocated to different portions of the memory. If you are having 1 GB file that is quite large, so you will be dividing this in 10 different blocks of 100 MBs, and those 100 MB blocks will be allocated in the memory, secondary memory. These may be contiguous, may not be contiguous, but one after another, you can track all the locations in the memory. So that is the concept of file allocation. Pre-allocation versus dynamic allocation means a pre-allocation policy requires the maximum size of a file be declared at the time of the creation request. Whenever we are creating a file, you must give the maximum size of that particular file in prior, so that it can avail a required amount of memory in your secondary storage. Required amount of storage in your secondary storage. Why? It will be helpful because suppose your file currently is taking 50 MBs, you are allocating 50 MBs. In future, it is going to increase size and it will be of 100 MBs. Then there might be a situation that we are not having 100 continuous space at that moment because some other file contents will be there in the memory. That's why pre-allocation is good if you are taking it. So other allocation techniques will be good with respect to pre-allocation. Dynamic allocation means your file may change its size, increase or decrease in the future. For many applications, it is difficult to estimate reliably the maximum potential size of the file. Tends to be wasteful because users and applications programmers tend to overestimate size. Suppose you think that currently it is taking 1 MB. In future, it may take 100 MBs or it may take 50 MBs. you are overestimating the size as a programmer, and you are reserving that particular size. It will be wastage of the memory, because in future this might be a case that you are increasing from 1 MB to 2 MB to 3 MB to up to 10 MB, but you have wasted 100 MBs or 50 MBs for that same. Overestimation may be a bigger problem in case of pre-allocation. Dynamic allocation allocate space to a file in portion as needed. If currently my file size is 50 MB, or in future it will take around 1 GB, then again it will not be a problem for me in dynamic allocation part. So we will try to implement dynamic allocation because it is useful in terms of memory. It will reduce the wastage of memory. But again, it is difficult to implement without, because it is dynamic allocation. Pre-allocation is easier to implement. You can directly say that my file is going to take this much size, so I am allocating this size to that particular file. In choosing a portion size, there is a trade-off between efficiency of the point of view of a single file versus overall system efficiency. So you need to check whether your file can be opened at a time or not. Your file will be usable in a single run through, or it will be splitted in several parts. So there are so many information regarding a portion, how much portion you will require for a particular file. So what are the alternatives we can find in between the pre-allocation versus dynamic allocation? Variable large contiguous portions. Variable large contiguous portions means variable, it is variable and it is contiguous. I am giving you a large block of memory. You can assign any particular file there, and the remaining size we can use for the other files as well. It provides better performance. The variable size avoids wastage in the file allocation tables are small in this case. If we are talking about blocks and variable size contiguous portion, those both are different type of schemes. Variable large contiguous means you are having different sizes in your secondary storage. Blocks means you are having multiple blocks of the same size in your memory. Like paging, you are dividing your memory in frames or in pages, and every page size will be same. Here again, every block size will be same, and you can divide your file in different blocks, and you can keep your values in the different blocks. Small fixed portions provide greater flexibility. They may require large tables or complex structures for their allocation. Contiguity has been abandoned as a primary goal. Blocks are allocated as needed. File allocation methods. Now these are the general methods we are going to discuss, that is contiguous, chained and indexed. Some more methods are there, but we will be discussing these three: contiguous, chained and indexed. So pre-allocation, talking about pre-allocation, in contiguous it is necessary. In chained it is possible to have a pre-allocation. Indexed, again it is possible. Contiguous is a very basic thing, chained something advanced, and it is super advanced, you can say. Fixed or variable size portions. Here variable size portions are there. Chained fixed blocks. It may be having fixed block or variable blocks. Portion size. Large, here small, It may be small or medium. Similar to that, allocation frequency, time to allocate, file allocation sizes. If you are going from contiguous to index, your complexity will going to increase. Your wastage will be reduced from contiguous to indexed. You can say this is complex to implement, but it will be having some least wastage in the memory.